Okay, let's start. Good morning, ladies and gentlemen. My name is Sonja Harris-Paulus of RWTH Aachen University, and I would like to welcome you in the name of the NFDI4Chem consortium to our first online seminar within the series of upcoming online seminars. The Gemeinsame Wissenschaftskonferenz has recommended our project for funding, so officially we will start on the 1st of October in the NFDI initiative within Germany. The question and answer session will be at the end. And so please, if you have in between questions, then just write them in the chat window. I will collect them and read them in the end and organize the question and answers session. Moreover, I would like to point out that the whole session will be recorded. We will put it on the web a little bit later, and we will cut out the question and answer session, so the data protection is guaranteed. I think we should not lose any more time. So Christoph, the stage is yours.
Thank you very much, Sonja. So very warm welcome from my side also. My name is Christoph Steinbeck. I'm a professor for chem informatics, and together with Oliver Köppler, I'm one of the co-speakers of the NFDI4Chem. First, a few words on the NFDI in general. In December 2018, the federal government of Germany and the individual states have agreed to fund a national research data infrastructure, as by now I guess you all know. The exciting part about this is the funding horizon of 10 years, which is going to be divided into 2 times 5 years, after which the situation will be re-evaluated. But you know, there has been expression that funding will continue. For the first 5 years, 90 million euros of funding in total were dedicated, of which 70 million are direct costs available for funding staff and getting actual work done. And eventually, after the first 3 selection rounds, there will be 30 consortia in all areas of science that will be funded in the NFDI. Individual consortia could and can ask for 5 million euros per year per consortium as a maximum. But de facto, if you divide 70 million by 30 consortia, there is really only around 2.3 million per year on average per consortia available. What is also very special about this whole project is that it's a non-competitive process in the sense that each area of science was asked to get their act together before actually applying. So it's a very collaborative effort. Next slide. From over 20 applicants in the first round, 9 consortia were initially funded, as announced by the GWK on June 26. The 9 successful consortia are shown here, and they cover, as you can see, fields from culture, social sciences, biology, medicine, and chemistry and engineering. And we were very lucky to be amongst the successful consortia in the first round. Next slide. Apart from those 30 consortia that will eventually be funded after 3 rounds of applications, there will also be a general directorate, an overarching organization, if you wish. There will be this will be a non-for-profit organization, and the directorate at the KIT in Karlsruhe has now been established. They have just moved into new rooms. People are being hired and have been hired. As you can see here, the director is Professor Jörg Suhre-Vetter, and additional staff is already available, and the directorate is working full steam. Next slide, please. So the NFDI for Chem is planning to build a national research data infrastructure for chemistry in Germany. We are overall 27 participants, out of which 8 have a special role in that they are so-called co-applicants, and they are also leading the individual work packages and form the steering committee. Next slide. A little bit of history. NFDI4Chem has really started off as a grassroots movement right when it became clear that the federal state and the states would fund the something like the national research data infrastructure. There are institutions within the NFDI4Chem and who have been participating in this process for a long time. A lot of universities, of course, in Germany, but also non-university institutions from the Leibniz, the Fraunhofer, and the Max Planck Society, and also the learned societies such as the German Pharmaceutical Society, the Bunsen Society, and the German Chemical Society are on board. So it's really a very broad movement. Next slide. In terms of scope, you all know that chemistry is one of the core natural sciences next to physics and biology, and as such it generates a very high volume of academic research, but also a lot of industrial developments. It has an enormous impact on and importance on the economy in Germany and also worldwide, and it also influences neighboring sciences such as medicine, biology, biochemistry, material science, and more. And it has, as a very broad natural science, but also generates data not only in its own right, but also for other neighboring sciences. Next slide. So why do we need something like a national research data infrastructure for chemistry? Many of you have witnessed this, the enormous development of information technologies in our lifetimes, symbolized here by the Cray 2 supercomputer from 1985. And then today, the iPhone, the smartphones in our pockets, they have a multitude, hundreds of times, in fact, more computing power than this supercomputer from 1985. And if you look at a similar comparison, actually over a much wider time range, we have here on the left side a laboratory notebook from the Kaiser Wilhelm Society from 1927 from an unknown scientist, and then on the right side an example of modern data management in chemistry, an academic lab notebook from 2019, and you can see that really not much has changed. Maybe the paper is a little bit wider and nicer handwriting, but that's about it. And that's not just an anecdote. This is really how data management in chemistry is done today. So the status quo in chemistry is that really information is written literally with a pen in a paper notebook. Of course, data is managed and generated also in a digital way by analytical instruments like our NMR spectrometers and LC-MS machines and others. They are often linked to local servers where the data could be stored centrally, but there is really no integrated information flow and proper information data management. And the worst part is really how we manage data when we publish them. They are published, they are being published in PDFs, and data is converted by scans or photographs of data, where information is destroyed when they are published in the form of PDF documents and Word documents. And it's very hard to get that information out again. Next slide. So our vision for the NFDI4Chem is fundamentally different. And we think it's going to be a quantum leap over the current status quo, but it's also going to be a rough road towards this quantum leap. We aim for a full digitalization of the data workflow from the very earliest time point of data generation in the lab to the final publications based on open standards and tailored for community needs. Starting from the experimental data in the lab, we will capture information in electronic laboratory notebooks in semantically rich form. And together from the data in the instruments, we will manage this data in laboratory information management systems to enable data analysis locally. And from there, fair and semantically rich data will flow into local repositories, and from there into public and global repositories where they can be discovered and reused by others to trigger a new circle of innovative science. Next slide. In order to accomplish this vision, we have documented a strategy in our proposal document. And we have, I forgot to mention that in the beginning, we have published this whole proposal in the journal Research Ideas and Outcomes, where it is available as a public, as an open access publication. You can find the link on the slides, which we are going to share with you, and it's also just easily findable on the NFDI4Chem.de webpage. So in the center of the whole idea is, as I mentioned, capturing data early in electronic laboratory notebooks and from devices, and then integrating it into semantically annotated data. And we call this area the smart lab, which is on the middle left of this slide here. And from there, data will be flowing into local and open repositories to be made available to the community. And this is all based on substantial developments of new and existing software, which is all going to be free and open, but also on open standards. And this has been mentioned a number of times, as well as on legal advice, policy development, and terminology. And of course, all of this will be made available to the public through a portal, and will be complemented by knowledge bases, as well as extensive teaching and training, and of course, help desk support. Next slide. Underneath all of this is a solid governance model, which we have been testing numerous times in large international infrastructure projects, which we have either led ourselves or participated in key management roles. And the central components for this management model is a strong steering and controlling model, complemented by measures of external advice and controlling by our community, by our stakeholders, as well as by the NFDI process as a whole. You know, as you can see here, there will be a considerable amount of advisory boards, which will have a strong influence on what we do. You can see in the published proposal, the original proposal was 140 pages, which now is a 100-page document in the Research Outcomes and Ideas journal that I mentioned, contains detailed measures and tasks, all with measurable deliverables, so that it is really very easy for the general public to control what we are doing and to give advice on our progress. Next slide here. So almost all of the aspects of the NFDI4Chem and also of the NFDI as a whole require a national and international context. Nothing that we do lives on its own and in isolation. Many topics in the NFDI, such as authentication and authorization or repository technologies and much more, will need to be solved for all consortia, for all 30 consortia in the NFDI. And therefore, there is a wide range of what we call cross-cutting topics in the NFDI, where the NFDI organization as a whole and the whole process will have to work together to avoid reinventing the wheel again and again. And then there is, of course, the international level. Data exchange is something that will need to happen on an international level with globally acting databases and processes. Many of you will have heard about the European Open Science Cloud, which is a context in which everything in the NFDI eventually will need to be embedded. And one thing that is very important for us as a consortium is the negotiation of standards. Chemistry is an area where certainly a lot of standards development will still have to happen. This is both data standards as well as what we call minimum information standards, where a field agrees on how to encode data and what is the minimum amount of information that you need in order to understand a particular piece of science. And those minimum information standards, ontologies, controlled vocabularies, they all need to be developed in quite difficult and sometimes painstaking processes on an international level. Otherwise, there will be no global adoption of standards. Next slide. So the next two slides summarize the key objectives which have been mentioned in the previous slides. So the main objective of the NFDI4Chem is, of course, to provide a network of data repositories that are able to capture research data in all areas of chemistry and link them to international repositories and make them available to the general public to enable better science. Objective 2 is about minimum information standards. You cannot achieve objective 1 if the information in those data repositories is not encoded in a meaningful and reusable way. So developing open standards according to the FAIR principles is our key objective, objective number 2. This can only be happening if we capture data very early in a semantically rich form. Otherwise, there will be no adoption because it's very painstaking to create data in a well-annotated form without objective number 3, where we will capture data in LIMS systems and electronic laboratory notebooks. And our second talk in this morning will be dealing with particularly this aspect. Next slide. There will be, or there is a clear need for a change in the heads of the people, in the minds of the people. And this is what the remaining objectives are about. We need to create awareness for the need of fair data management and for the processes of good RDM, and also integrate data science and fair data management into the curricula, which is our objective number 4. As I mentioned, there are a lot of cross-cutting topics in the NFDI, which will need to be worked together to avoid reinventing the wheel. And that's its objective number 5, maintaining close relationships with our neighboring NFDI consortia. And then last but not least, in objective number 6, we will look into the legal aspects of fair data management. Most of the data will be uncritical and can be easily and openly shared, but there may be cases where people have doubts regarding the legal aspects of open data management, and this is our last objective. As I mentioned, we will need to work with, or we want, and it will be very beneficial to work with the international community on standards and other data sharing aspects. And there are, of course, already existing movements such as the GoFair, the EOSC, but also committees in the IUPAC with which we will happily collaborate as part of the NFDI. So what are the next steps? I mentioned we will be starting in October, on October 1st, in fact. So one thing that is currently being worked on is the consortium agreement. In October and later, in October there will be 9 consortia starting. Later there will be 30. it's clear that all of these consortia need consortium agreements to distribute the money and lay a foundation, kind of like a constitution, in order to work together. These consortium agreements would, in the worst case, be negotiated by every consortium on their own. This is something we all want to avoid. And so the NFDI headquarter, the DFG, and an office of lawyers has been working on a joint consortium agreement. We will have our kickoff meeting in the middle of October. One thing that is going to be very important is to establish the advisory boards in order to create a good controlling model, which I mentioned in an earlier slide. The advisory boards that we have currently planned are, of course, boards that capture the national research community and an international SAB, but also a particular board dedicated to industry and one board dedicated to publishers, because publishers play a key role in creating demand for open data sharing. If people want to publish a paper, then the data associated with the paper must be deposited, and that is something that only publishers can really demand. Another aspect that is going to be very important is our international working groups for standards, both for data standards as well as minimum information standards. And the key central areas in chemistry will need such working groups, and that includes organic chemistry, inorganic, theoretical chemistry, and more. And with this, I'm at the end of my presentation, and I thank you for your kind attention, and I would like to hand over to Nicole for her presentation on electronic lab notebooks.
1 second. Next talk is starting in 1 second on the ELN and the smart lab vision. Oop. Starting right now. So Nicole, are you?
Yeah, I'm here.
Okay, we can hear you. Okay.
Just waiting for the presentation.
Yes,
mode.
presentation is online now. Yes.
Okay. So good morning all together also from my side. And I will now present the Smart Lab vision of the NFDI4Chem. And for those who are not familiar with the NFDI4Chem proposal, this is described in task area 2 with interfaces to all other parts of the work areas. Contributions to the vision of the NFDI4Chem in the task area are given below with the names of the participating colleagues. All the listed colleagues take part in the developments, and they are doing that by either being hosts and advisors of the personnel that will work in the NFDI4Chem, or they're contributing in kind. And as you see, many scientists are involved. I hope I didn't forget anyone. All colleagues are already engaged in the generation of infrastructure and provide the scientific expertise for selected parts. And in that case, people given in bold have a special responsibility because they will lead subtopics in ELN development for certain sub-disciplines in the ELN. So Felix Bach, just for the first slide again, has a very special role and is therefore given separately. The Computational Center of KT will provide infrastructure and personnel for the ELN as a service, and several other critical services in the task area Smart Lab. Next slide. So this image here shows the traditional documentation of experiments. As Christoph already mentioned, during the last decades, almost nothing changed with respect to our way to manage data and keep records of scientifically important information. So this has to be changed to allow faster progress by what many people call a digital change. And in this funding period 1, we will focus on the development and establishment of software. So this software will enable scientists to change their work habits and documentation habits. We want that every chemist has access to the infrastructure and software that allows to work with an ELN, and that the scientists can access and work with the data digitally. This is meant with the image on the right-hand side, given as just one example how the work processes could look like. This has a huge impact not only on the speed and the quality of the work of the single scientist. Such a digital change is also the basis for the creation of larger databases. And that means in the end then the accumulation of knowledge. For the wording smart lab, one might think of sophisticated applications, but I won't describe that here. Of course, we want to develop and include fancy applications for scientists, but the main task that we have at the beginning is first of all to enable the necessary digital change and to cover the basic requirements that we have. Okay, next slide. In the end, we want to serve the scientists. So the expectations that scientists have and which should be mirrored then in the NFDI4Chem is scientists should work in a digital way. Their instruments should be connected with the digital environment. There should be, at least to some extent, independent of commercial software. Scientists want to work in a flexible way with data and infrastructure to be at the end of the day faster with their work. So that's the main aim from the point of view of the scientists, I guess. For the communities, they should benefit from reliable work, which is documented in a suitable way. And another very important point is that scientists want and need to be supported in their efforts to realize a digital change. This is a huge effort of the NFDI4Chem with the limited resources that we will probably gain, but it's absolutely necessary. Okay, next slide. Here summarized the main principles of our work with respect to build up the required infrastructure of the NFDI4Chem. The NFDI4Chem will support in terms of own development one open source solution and not several ones. So I want to stress this term own development. The limitation in terms of development efforts is necessary to maintain a strong development team. That means all developers will form one team coordinated for this task at KIT, but with different development sites supervised by the local experts at their sites. But this is only one of the planned offers. NFDI4Chem will be open and flexible in terms of including other solutions, for example, by collaborations. Other open source tools will be installed if they provide additional value for the consortium and the scientists, and the alternative solutions will be covered by teaching and training and can therefore also be included to the main infrastructure, of course, if technically possible. Okay, next slide. So why do we think that Smart Lab concept is valuable and should be included, including then the devices, the software, and the ELN? Why should it be part of the NFDI4Chem? We are, as far as we know, the only consortium with a detailed and very concrete plan to solve these technical issues that arise directly at the side of the scientists. The point is that the success of the NFDI4Chem will rely on the digitalization of these work processes. And the success of the NFDI will strongly depend on an efficient data flow. So the availability of a virtual work environment that covers the daily work is of highest importance and therefore has to be provided for all chemists. So now, to allow the capture of data at the earliest point in the research data lifecycle, and this is what we want, chemists need to integrate devices, such as analytical devices, and here in this figure is shown an NMR instrument as an example, to their digital workflow, and to ensure that data is handled and stored along with its context and further relevant data, such as notes and observations. They need an electronic lab notebook. It is very important to establish an efficient model to transfer or link the data from the devices and the ELN. And just to mention that, Christoph mentioned that as well, an efficient flow of data and an efficient interoperability of the single elements of the infrastructure based on the fundamentals such as common standards. And only by this we can ensure that the data are available and that they can be reused by the community. To reach this aim, we will work together with different stakeholders. This is shown in here, which are, in case of the devices, as a first element, the vendors of the devices. I saw that a question in the chat went in the same direction. The chemical industry is another collaborator, and of course, academia. For the documentation and management of the work in the ELN, we will provide subdomain-specific modules that are incorporated into the basic chemistry ELN. And these subdomain-specific modules, they are shown here in this image via the small panels, will ensure that the needs of all main fields in chemistry are covered. And just to mention those subdomains once, this is organic chemistry, inorganic chemistry, physical chemistry, polymer chemistry, biochemistry, pharmaceutical chemistry, and medicinal chemistry and analytical chemistry. So the additional software tools should be available independent of the ELN. That's important, but they're also embedded to allow their direct use in the software. In particular, tools to view, convert, and approve data are required in terms of additional software tools. The ELN is a crucial instrument in the research data lifecycle, as said. And the reason for that is that it can be used to transfer the obtained data into repositories directly. So the direct interaction of ELNs and repositories will facilitate then the deposition of data. And this is the point where scientists will save a lot of time and effort in future. So worth to mention is the combination of ELNs and repository is a real benefit for the scientists for sure, but it facilitates also to meet the requirements of the funding agencies in future. Okay, next slide. The work program of the NFDI4Chem is quite challenging, in particular also for the area Smart Lab. I depicted only several of the aims, challenges, and solutions to give a few examples of the most relevant issues that we have to deal with. And for part one, the device integration and management, our main challenge is here the development of processes that include, at least as far as possible, different techniques, old equipment, and the handling of proprietary data in the universities. To solve these challenges, we will reserve personnel for hands-on advice and, if necessary, also on site. We will create a knowledge database to exchange and disseminate the identified solutions. Okay, next slide. Challenges on the way to offer an ELN for all scientists are in particular to work for the needs of 7 subdomains. I mentioned that. So this has to be solved by 7 development sites and a coordinating group at KIT. A major invest in the NFDI4Chem, in addition to that, is the offer of an ELN as a service for those who can't care for their own software installation and their own administration. This is only one important measure to include and support all scientists in the, independent in the end of the group size and the options that a single scientist has. Next slide, please. At last, the challenges for software development are also manifold. There are many challenges on the software development side itself, but also challenges to satisfy the users by high usability and functionality of the software. For software development, as for many other fields in the NFDI4Chem, we are only strong in collaboration. We will use open source code and tools, combining existing solutions and hopefully with benefits for all. So several people in the NFDI4Chem are already developing software, chemistry software. We will join forces and collaborate with others as well. Okay, next slide. So coming now to the current status, we won't start from scratch. That was said before. We will focus on software, but also models and infrastructure that's already available. And we will extend and improve this available solution systematically, step by step. The green colored panels in here indicate where we are at the moment, at least I hope roughly, and where we want to be in 5 years. So this 5-year level given in gray is something that we need to reach in any case. With the example, in organic chemistry, I can explain that roughly. So if we can't manage to include, for example, the inorganic chemist with respect to the ELN, then we'll, by adding the necessary functions and needs to the ELN, then we will lose the support of the community in the long run. And this is what we have to avoid in any case. So only if we can mirror the needs to the needs of the scientists to the ELN, we will be successful with the contributions to the repository then in the second step, and only the availability of the data will allow successful research data infrastructure. The benefit that we have is we know already what we need. We've already defined possible workflows. And what I can do now, I can give some examples how that's realized for organic chemistry, showing that the transfer of data from the devices to the ELN and then into the repository CareMotion, how that works in that case. So in the following slides now, I'll give in very brief only a few examples how the current ELN with this focus on organic chemistry looks like. And many functions can be used in as other subdisciplines. But there one should keep in mind that a lot of further development has to be done to allow then a comprehensive work with data and information in other subdisciplines in the end. At least I hope that I can demonstrate the value of the infrastructure if it is designed according to the needs of the scientists. So this is the case here, and this is the contrast to the more generic software or commercial solutions which cannot be adapted and which are existing at the moment. This slide shows one option in the user interface, and in that case for reactions, as you see, and for other modules like molecules, assays, well plates, and generic elements, this is available as well. Next slide. So for every element that I mentioned, for that the reactions are only one example, several tabs are available, and these tabs summarize then again under specific topics, additional information and data. For reactions, in this example, the further information tabs or pages are additional properties, references, analysis, for the addition of analytical data, for example, and connection to other databases, such as SciFinder as just one option. Next slide, please. Via the tab analysis, so that was shown in the slide before as well, which is one option to add additional data to reactions or samples. User can upload or transfer data files directly. Depending on the format of these data files that's used, the ELN can also process the data and provide some analysis tools. I will show that later in the slide. In parallel, images and, if possible, open data formats are generated. So in addition, the user can select the type of measurement that was done by selection of suitable terms in the ontologies that are implemented. At the moment, we have for those measurements with analytical devices only one ontologist implemented, and that's the CHMO. Okay, next slide, please. And as said, analytical data can be processed in the ELN and can be then visualized for further work and analysis. And this is done by an integrated data editor. File formats that can be processed at the moment are currently, unfortunately, limited. They're limited to the most common ones from mass spec, IR, Raman, and one-dimensional NMR data. But the extension of the function is exactly what is planned of the developments of the NFDI4Chem. So the benefits for the scientists are manifold in that case. On the left-hand side, you see the inbox of the ELN. The inbox catches data coming from connected devices and allows their storage with the reactions or samples so that the data then should be assigned. After the storage with the assigned ELN elements, so in that case, samples or reactions, the editor can be used then for the analysis, and the results are directly stored in the ELN. So as a summary, this process avoids external software and all needs to store or shift data from any other system. Next slide, please. And if the scientists decide then to publish the results and want to deposit the data in the repository, they can do that with a few actions. The most important feature is all scientists using the ELN with the data transfer options embedded can manage this process at every site. For example, giving Sonja's group in Aachen, she transfers already data from her instance, ELN instance in Aachen, to the repository hosted at KIT, and that in the exactly same manner as the KIT scientists disclose their data there. And I won't go into details for the repository. This does not fit to this time schedule that we have here, but I want to just give one additional example for data in the repository. Next slide, please. So here you see the summary of the analytical data in the repository for one example that I selected. And the data coming directly from the ELN can be edited in the repository if necessary and are then published there. With the registration to the repository then for standard users, one has then the direct access to the full data and all functions. So such options as described for direct data transfer to repositories, as I described that here for the Chemotion repository as one example, are very important for other initiatives and activities of the NFDI4Chem, and will also be enabled for other systems within the working and program time of the NFDI4Chem. Okay, next slide. For the Chemotion repository, all data can be accessed in a similar way as it was described for the ELN. So the spectra editor can be used to visualize data. And this is here shown just for the example protein NMR and carbon NMR. Users don't need the additional software that's usually used, and they can access the data directly. They are not limited to PDF file formats as in many other repositories. Okay, next slide. So now besides the work on the chemistry-specific applications, which I described in brief, we're working at the moment on a more flexible use of the ELN that's provided. So also the use for other disciplines if possible. So this is for sure most attractive for disciplines that are working with molecules or disciplines related to chemistry data. And at the moment, we're launching a general and generic module of the ELN, allowing to store data in a flexible way without any pre-formatting, as this is given for the chemistry-focused ELN. And additionally, a new module will be available that allows the configuration of the ELN contents by an administrator. So the aim is here to allow each scientific domain to define new instances that are then incorporated into the processes of the ELN. Examples for such new instances can be, for example, cells, organisms, technical materials, but also hardware or anything else. So it should be quite flexible. And these options then will allow some other people's allow entry and will also allow the collaboration with other disciplines. So this is now my last slide. As said before, for all developments, we will rely on the acceptance by the community. And this is our aim that we pursued constantly with different measures. Every scientist is invited to participate and to collaborate, giving advice, testing, and using the infrastructure. We will include the community by the measures that are given here. So examples are workshops, training modules, tutorials, and roadshows. We will also install help desks that are then the constant address for questions and problems. In summary, every input, every participant, every user is welcome. So with this, I want to thank you for your attention, and I want to hand over to Sonja again. Thank you very much.
Thank you, Nicole and Christoph, for the informative talk. Thank you very much. And as you just heard, the interaction of NFDI4Chem with the community is key to the success of the whole NFDI4Chem or NFDI process. Thus, we rely really on the input and the feedback of the community. So the scientists' needs are in the focus of all our efforts. Hereby, I would like to open the question and answer session. And in the chat window, I have already seen that there are numerous questions.